Okay, I'm gonna start the second part of our lesson, solving some questions, past paper questions related to the differentiation. Okay, in this question, they give me this equation, y equal to 3 over 8 x to the power 4 minus x squared plus 5. And they want me to find the derivative of this function. What I'm gonna do here, I'm gonna say that dy over dx, 4, I'm gonna multiply it by this amount, I'm gonna get it to 3 over 2, and x to the power of 3 when I subtract 1, and minus 2x. So this is the derivative of our function. This is part A. In part B, find the gradient of the tangent to the curve at a point P is 8. The gradient of this one equal to 8. So this means the derivative of this function equal to 8. So I'm going to say 3 over 2, x to the power of 3 minus 2x, it's equal to 8. And they want me now find the coordinates of point B. If I want to find the coordinates of point B, I need to solve this equation. And to solve it, when it's equal to 8, I can use the graphing calculator for that. I'm going to get x equal to 2. Okay, how can I get the point now? I need to replace this 2 in the original function, to get the coordinates of this point. When I replace it, I'm going to get 3 over 8 multiplied by 2 to the power of 4 minus 2 to the power of 2 plus 5, which is equal to 7. So in this case, the point what I got is 2 and 7. This is for the first question. This is the second question. We have the equation of a curve C is y equal to 3 over 4 x to the power 4 and 1 over 3 x to the power 3 minus 2. We need to find also the derivative of this function. So the derivative of this function, which is part A, it will be 3x to the power of 3 plus x to the power of 2. And I'm going to go on and go for part B in this question. So we got this function now. Point A, it's on the curve C. The gradient of the tangent to the curve C at point A is equal to 4. So the gradient, it's equal to 4. So I'm going to say 3x to the power of 3 plus x to the power of 2. It's equal to 4. And using also, again, the graphing calculator, I'm going to solve this one. I'm going to get x equal to 1. We need to calculate the coordinate of the point A. The same thing, I'm going to go for the original function and replace x. I'm going to get 1 plus 1 over 3 multiplied by 1 also, minus 2. So the last answer, it will become negative 11 over 12. So the coordinates of this point will be 1 and negative 11 over 12. Okay. Now going for the next question. If we can draw this one, remember you can draw it using the graphing calculator to get the answer. You're going to get that this point will be on the curve, which is 1 and negative 11. So it will become like here and going for this point. So this point, and this is the tangent which is passing through this point. Okay, you can get it using the graphing calculator. Thank you. This is question number 3. Also, we have function given for us here. And I want to find the derivative of this function. The easy way is just to keep x up. So I'm going to make it f of x equal to half x to the power of negative 1 plus 1 over 8 x to the power of 4 and minus 1.625. And if I want to find the derivative of this function, I'm going to say dx over dy, or you can find it as a prime of this function. So it will be, I'll multiply negative half by 1 over 2, it will become negative half. X to the power of negative 2, because negative 1 minus 1, it will become negative 2. And 4 times this part, it will become 1 over 2 x to the power of 3, and this is the derivative of this function. Okay, in the next question, they asked me to calculate f of 1. I think this is an easy part. We need to replace 1 in the original function. So f of 1, it will be 1 over 2 multiplied by 1 plus 1 over 8 minus 1.625. And if you will solve this one, you can get it also using the calculator. You're going to get the last answer equal to negative 1. And if they want in part C, f prime 1, so I'm going to replace 1 in this function. So it becomes negative half multiplied by 1 to the power of negative 2 plus half multiplied by 1 to the power of 3. And when you simplify all of this, also you're going to get the last answer equal to 0, because it's negative half and half, which is equal to 0. Okay, I'm going for part D now. We need to sketch this graph. Sketching this graph, this means I need to use the graphing calculator. We need to sketch the graph of x. As you know, we need to replace the function in the calculator. We're gonna get this graph. You're gonna find it like this. So this is the graph of our function. It will pass through this point, which is negative 1.97 and 0, and it will pass through the mid, or this point equal to 1 and negative 1, this point equal to 1.81 and 0, if you can sketch it, and in this one it's passing through 0.308 and 0. So this is the function what I need to draw. I'm gonna get it like this into two parts. Okay, I will continue my work doing part. We need to show this graph if the question will ask me to sketch it. We need to draw the tangent line A to the graph of y equal f of x at point x equal to 1. So what is x equal to 1? X equal to 1 here. So if I draw the tangent of this point, it will be a horizontal line passing through this point, if you can see it. So this is point A here. Okay, so it's a horizontal line passing through this graph. Okay, I'm going for the next part of our question now. Find the equation of the tangent line A. So the direct answer, I'm gonna say it's y equal to 1 because it's a horizontal line passing through this graph. I'm going for part G now. The graph of y of f of x and the tangent line A have a second intersection, point K. So to find point K, first of all, we got this point, and the second point will be point K, this point. Okay, use your graphing display calculator to find the x-coordinate of this point. So to find the x-coordinate, I need to find it using the graphing calculator, and I'm gonna get that it's passing through this point, which is in this case, K equal to negative 1.65. And this is what we need to find in this question. Thank you. Okay, this is the last question in our assignment. A steel pail is made in the shape of a cylinder with internal height h centimeter and internal base radius r centimeter. The steel pail has open head. The inner surfaces of the pail are to be coated with a protective resin. Write down a formula for A, the surface area to be coated. First of all, the surface area, it will include the down part, which is the circle, the base of the cylinder, and the round surface area. So we know that the area of this circle, it will become by r squared, and the area of the second part, it will be only the frame around multiplied by the height. So I'm going to say it's 2 by r multiplied by the height, 2 by r h. So if I want to find the total surface area of this shape, I'm going to say A equal to by r squared plus by, or 2 by r multiplied by h. So this is the area what I'm going to use. Okay, going for the second part now. The volume of the steel pail is 10,000 centimeter cube. Write down in terms of r and h an equation for the volume of the steel pail. Okay, in terms of r and h, I'm going to put it equal to 10,000. So this is the second part, part B. 10,000 equal to by r squared h, which is the volume of this shape cylinder. Circle multiplied by the height, so it's by r squared multiplied by h. So if I want to write now down in terms of r and h an equation, so we got the equation here. We need now to show that A is equal to by r squared plus 20,000 over r. If you can see here in the area, we don't have any more h, while we have here in this rule h. So what I'm going to do, I'm going to get h from this part. So h, it will be 10,000 divided by r squared. So this is the h. I'm going to take this h and replace it in this function to get my answer. So this is what I'm going to do now. I'm going to say in part C, A equal to by r squared plus 2 by r multiplied by the h what I got, which is 10,000 over by r squared. And if I want to simplify this more, I can simplify with by, 1r with 1r. I'm going to get 1r only in this case. So the last answer, it will be A equal, and you can multiply 2 by 10,000, so it become by r squared in this case, by r squared plus 20,000 over r. So this is the new area what I got. Okay, going for part D now, they want me to find the derivative of this function in terms of r. We don't have another variable, we have r, so we can find it from this equation. If I want to find it, I'm going to get it equal to by, which is this part D, by, or let's say I'm going to multiply 2 by this amount, so it will become 2 by r. And I can put r as an r inverse in this case, so I'm going to get it equal to minus 20,000 r to the power of negative 2. To put r to the power of negative 2, I can write it in another way, which is over r to the power of 2. So this is the derivative of my function. Okay, going for part E in this question, using the answer to part D, find the value of r which minimize the area. So we need to minimize the area. This means I need to put the area or the derivative of this area equal to 0. So I'm going to say now 0 equal to 2 by r minus 20,000 over r squared. And if I want to solve this one, I need to solve it using the graphing calculator. I'm going to get, or you can use it normally, whatever you want, you can do. Okay, it's easy to use the graphing calculator for that. So I'm going to get r equal to 14.7 centimeter. Okay, now I'm going to go for the next part, part F. In part F, they asked me to find the value of this minimum area. If I want to find the value of the minimum area, this means I need to replace r in this rule. So I'm going to say area equal to by multiplied by 14.7 squared plus 20,000 over this r, which is 14.7. And I'm going to get the area after solving all of this equal to 2040 centimeter squared. Remember to put the unit. Okay. Now going for the last part of my question, they said in part G, find the least one can of protective resin coats a surface area of 350 centimeters squared. Find the least number of cans of protective resin that will coat the area in part F. If we have the total of the area 2040, so I'm going to say the total area or the big area, which is 2040, divided by the area of the small cans, which is 350 centimeters. I'm going to get it equal to 6 cans. So it will fit in 6 cans. Thank you.